All right, so let's do a quick roll call and then we'll get started. So we have Dave, Dhanushri, Chris, Aryan, Neil, Prisha, Rehan, Sarah, Srivatsav, Sriyan, Sunarka, and Vishal. So welcome back, Sunarka. I know you had a good trip to India. Welcome back.
Yeah, thank you.
Okay, so the the news for today is that starting today, which is the first day of the month February, we are starting a fresh iteration of the entire SAT syllabus that we have that we have covered or not covered. So basically, starting today, we'll go through each and every topic that we have to cover as part of SAT preparation, and we'll try to cover all the topics from beginning till the end. Again, following Khan Academy in next 5 to 6 months. We might be able to go a little fast for some of the topics, which sounds easier, but we'll make sure that this is our one more attempt to finish all the things that we need to know as part of SAT preparation before your school year ends. Okay, that's the plan. I mean, we might take few weeks here and there extra, but we'll try to see if we can cover it all one go. Okay, so that when you guys, if anybody is planning to take SAT exam, let's say in May June time frame or July August time frame, at least you would have covered the whole syllabus one more time. And as I keep requesting, now since this is one final iteration before this school year, my request to you all would be that whatever we learn in the class, go back to Khan Academy, do the unit test, do some sample papers, just to make sure that whatever you're learning, you're able to practice that as well. Make sense? And my biggest reason for happiness would be if I see you guys or some of the kids in the class who are taking up SAT exam earlier to get a better score than what you would have got before. I mean, my goal is to get a near perfect score in maths. That's what I'm working for, and that's where I'm committed to help you guys. But let's make sure that we work together. What that means is you will not only learn things in the class, you will do practice, and whenever you come across some interesting problem or some difficult problem, don't hesitate to share that with me. I mean, the ideal situation would be share those questions in the group so that not only you but your friends in the group also are able to make an attempt to that, because everybody's score would be individual, but then we can learn a lot from each other. Okay, I mean, obviously while I'm committed to teach you guys, but nobody is stopping us from learning things from within the group, so that each and everybody in the group does a better performance in the SAT exam. Yeah, that was the intent part of it. Let's go to the content now. So, who all got a chance to look at what all we're going to cover today? So I'll just quickly read it out for you guys. So this is the first unit. Yes, Ravya.
Hi, sir.
Okay. So this is the first unit of SAT prep, which is more around learning or solving linear equation and inequalities, understanding how that concept helps us with solving word problems, and then understanding the linear relationships and relate that with all the concepts of linear equation that we have learned or that we are going to learn in next few classes. Is that okay? Now, okay, cool. So, first thing first, everybody in the class would know what do we mean by linear equation. But is there anybody who wants to redefine it or just say it in his or her own word? What is linear equation? Anybody? Yes, Dave.
It's like an equation that changes at the same rate throughout the graph.
Okay. How about you, Vishal?
It's a straight line
that representing a constant rate.
Okay.
An equation that can help you plot a straight line.
An equation that can help you plot a straight line. A good starting point. So, some of you who have heard me talk about linear equation might get a little bored, but bear with me, just for one more second or one more minute maybe. Whenever you talk about linear equation, see, communication is the mother of anything and everything that we learn. So even when you talk about math, that starts with communication, or here the medium of communication is English, right? So English would be again a source that will help us relate the concept of linear equation as well. Okay. Now if you look at linear, if you break it out, break it into two pieces, you have a line in it, meaning something equation. When you say equation, something which has an equal to sign. That's what qualifies to be called an equation. Meaning an equation which represents a line. Now, what is a line? Line is nothing but something like this, something like this, something like this. And what is so very unique about a line is it is something which is predictable. If you know that one point is here, you can predict what will be the property of this point, what will be the property of this point, what will be the property of this point in that given linear equation. If you're talking about an equation of a line, that is predictable. Imagine a situation like this. You know one point, you probably might struggle a little bit more to find out this point because it's not very straightforward, it's not very predictable. Or in more mathematical terms, the slope, the inclination of the line here at this point versus the inclination of this line at this point, right? Or the steepness of this point around this point is changing, right? Wherein here if you look at this point, this point, this point, the steepness or the slope is remaining constant. Now, I'm mixing two things, right? I said a line, and then I'm talking about steepness or the slope, and then I'm saying predictability. Now, if you bundle them all together, how you will relate is, before I go further, right? Steepness or slope of any line, what does it actually mean? Yeah?
The rate of change from one point to another, like the rise over run from each point.
Okay. What is so I got one definition of steepness where Praneeth is saying that when you talk about steepness or slope of a line, it means what is the rate of change of one thing against the other thing. Any other definition that you guys can give in a very simple way? Dhanushree, Shravya, Srivatsav, anybody?
Can you read it again?
Yeah,
what,
sure.
what did it say?
My question is, how do you relate a slope or a steepness of a line? Or how do you define it? Let's say if you assume that your teacher doesn't know anything and if you have to explain that to me, how do you define it? A steepness or slope of a line? Yeah, Prisha, anybody? Yeah, Vishal.
You can find like the slope of the line using slope point form, or you can see how if the line is going faster or like is it going slower to see if it's more steeper or less steeper.
Okay. Let's see what Prisha has to say. Yeah, Prisha, go ahead.
The slope is essentially just the change in y over the change in x.
Exactly. So again, I am not giving you guys enough clues because here in this class I assume that you guys have learned a lot of things by yourself by now, and some of the things that you have learned before. So let's try relating it. So now, whatever I was saying so far, that was just blabbering. no interesting concepts, no correlation with math. I was only talking with respect to English. Now let's get serious about maths. Yeah. So first thing first, whatever concept we have learned with respect to a line is nothing but a shape that gets formed by joining 2 points. Yep. Everybody with me? Shreyan, Sunarka, Vishal, everybody? Dave?
Yes, sir.
Now, so I'm saying there are 2 points that I'm joining to make a line. Now, how do you know these points? These points have no point if you don't recognize them, or if you don't identify their properties, their location, their whereabouts. So that is where this coordinate plane comes into picture, right? If I'm putting a point here versus putting a point here, what I'm doing is I'm relating that with my edge of the board, and then I'm identifying this point. Or how far is this point from this edge or this edge? That helps me recognize this point. Similarly, if I put a point here, I will say, okay, this is this far from the top of the top edge, and this far from this side edge, or this far from this edge. Correct? Everybody with me? Chris? I'll keep calling out names, okay, just to make sure that you guys are with me always, okay? Not trying to put anybody on the spot. So you always recognize a point with reference to something. You know my address because you will say, okay, my house is 10 meters away from neighbor 1 and 20 meters away from neighbor 2. And if you know my neighbor 1 and neighbor 2's address, you can relate or locate my place. Correct? Same thing happens with respect to coordinate planes. Coordinate planes are nothing but you form coordinate planes by putting 2 number lines. This is a number line starting from 0, 1, 2, 3, 4 goes on, minus 1, minus 2, minus 3, minus 4. This is something that you guys would have probably learned in 2nd or 3rd grade. What is a number line? This is one number line and this is another number line. 1, 2, 3, 4 and then minus 1, minus 2, minus 3, minus 4. This number line which is horizontal, we call it x-axis, and the number line which is vertical, we are calling it y-axis. So when there are 2 number lines perpendicular to each other that and meeting at the origin point, which is 0, this is the primary definition of your coordinate plane. Everybody knows it. I'm just repeating myself just to make sure that any of the basic concepts are not overlooked. Now you have 2 number lines. This will become your reference lines to locate points. Now if you look at this point, you say, okay, fine, this is 2 units away on the x-axis and probably 3 units away on the y-axis. So this 2 comma 3, 2 is your x distance along the x-axis, 3 is your distance along the y-axis. That helps you recognize the first point or identify the first point or locate the first point. Similarly, if you are talking about this point, here you have, let's say this is 5, 3, 4, 5, and this is probably 4, 5, 6. So this is 5, comma 6. Now you have located both the points. Correct? So when you join these 2 points, that is helping you draw a line. This part is very clear to everybody, right? I'm assuming that. Okay. Savya, Rehan, not everybody? Chris? Yeah, okay. So now the most basic concept is, okay, fine. If I'm talking about joining 2 points, I know how to locate those 2 points, and when I join them, that makes a line, straight line. Now when I'm talking about slope, look at this line versus this line. Let's say I'm putting another line like this, and this is, let's say 3 comma 2.5 and maybe 6 comma 4. Now look at this line and this line. I mean, technically I shouldn't be calling them line. These are line segments basically. Yeah. So look at these two lines. Visually, if you look at them, you can clearly say that okay, this is less steep, this is more steep, or this slope is less, this slope is more. Now, based on whatever definition you guys gave me, I'm just kind of putting them all together. This is less slope, this is more slope, this is less steep, this is more steep. Now, why? Steepness is defined by, or slope is defined by, change of y for every change of x. So if you look at this line, see here, when it changed from 2 to 5, the x value changed from 2 to 5. So here in this case, the first one, let's say I'm calling it slope 1, which is x changed from 2 to 5, y changed from 3 to 6. So this was the change in y, and how much was the change in x? 2 to 5, I mean 5 to 2. So this was 5 to 2. So y changed from 3 to 6 and x changed from 2 to 5. So it was 6 minus 3, 3 by 3. Here it was 1. So in the case of the first one, the slope is 1. Now if you look at the second one, what is the slope here? So here, slope 2 is change in y. So y changed from 2.5 to 4. So 4 minus 2.5. This was the change in y. And how much was the change in x? 3 to 6. So meaning 6 minus 3. This was the change in x. Now you look at this. 4 minus 2.5 is 1.5. And 6 minus 3 is 3. How much is the slope now? 0.5. Look at this guy. Your slope was 1 and here your slope is 0.5. Now we have a mathematical way to justify what we were trying to say. So what I'm saying is, now you look at this guy's slope, that came out to be 1. And when you look at this guy's slope, meaning how much was the change in y for the change in x, this was 0.5. Now you can say with confidence with data, saying this guy has more slope, this has less slope, or this is more steep, this is less steep, because here the rate of change of y is more than the rate of change of y in this case. Or you will say here the slope is 1, meaning for every change of x, every unit change of x, y changing by 1 unit. Here the slope is 0.5, meaning for every 1 unit change of x, y is changing only by half a unit. Is it making sense to everybody or only to me?
Yeah.
Yeah. So now couple of things we clubbed together. One thing is we looked at how do you locate a point in any coordinate plane. If I just go and put a point here on the wall, I'll just create some mess on the wall, that's it. But I should be able to locate a point with reference to something. Every day, you guys deal with Google Maps, you see Apple Map, Google Map, or address, postal address, zip code, whatnot. All those things are an extended form of this, where you're trying to locate a location or a point with respect to something which is given as your reference. So we learned how do you locate a point, what is the relevance of a coordinate plane, and we interpreted coordinate plane in the simplest form, where we are saying, okay, coordinate plane is nothing but two number lines meeting each other at 0 and are perpendicular to each other. Yeah, and then we say, okay, fine. We know from a geometry that if you have 2 points, if I join them, that makes a line segment or line, whatever. If you just join them, it becomes line segment. If you extend them further, that becomes a line. So then we related that with what do we mean by slope of a line. How is this line different from this line? What is the primary way to differentiate and say, okay, this guy is different from this guy, because both have different slope, both have different inclination or steepness, and we looked at the mathematical side of the story. Correct? Any questions so far?
No.
No questions? Then if you guys don't ask questions, I have all the reasons to bother you guys. I'll just keep calling out names. Shravya, Prisha, Rehan, Sara, Neil, anybody? Any questions? Srivatsav?
No, sir.
No questions? Okay. Sunarka, fine so far?
Yes, sir.
Okay. So basically we just looked at the correlation between a coordinate plane, how do you relate points, how do you draw a line, how do you derive the steepness or slope of a line. So the only takeaway from this is that if you have two lines, you will say this is my slope and this is how I can derive the steepness of the line. Now look at this coordinate plane. I'm saying the steepness of the line. Fine. That is just telling me how quickly y is changing versus how slowly it is changing with every change of x. This is one part of it. Now extend this line. What happens? It might or it will intercept with your reference frames or the number lines that you have, which we are calling as x or y axis. So wherever it crosses the y axis or touches the y axis, that is called y intercept. Wherever it touches the x axis, that is called x intercept. Yeah? Yeah? If I give you guys a linear equation or equation of a straight line, y equal to 3x plus 5. Just by looking at this equation, okay, before I go further into it. So, as you all would be knowing by now, I am still repeating myself, that if I have an equation where the maximum power or the exponent to the variables is 1, that is when it qualifies to be called a linear equation. Meaning, that is when it plots a straight line. Are you guys with me? You will never have an equation like y equal to 3x squared plus 7 plotting a straight line for you. Never ever. If it does so, I should stop teaching. Okay? Or you should stop studying as well. It will never do that. I mean, that's what I'm trying to convey. So if you ever have an equation where the maximum power to the variable, any of the variable, be it y squared or y cube, or be it x squared or x cube or x to the power 8, whatever it is. If ever the power to the variables or any of the variable is not 1, that will not plot a straight line for us. So the only condition we have for any equation to be a linear equation is it would be something in the form of, let's say, 4x minus 3 by 2y equal to 8. Why I am calling this a linear equation? Because the maximum power to the variable x is 1 and maximum power to the variable y is also 1. Okay? And it doesn't mean that if I have an equation like 4x minus 1 by y to the power minus 3 equal to 8. Will this be a linear equation? Because maximum power is only 1. Here the maximum power is minus 3. So it is less than 1 or less than 1. But will this be a linear equation? It's a trick question. I mean, anybody can answer. Chris, give it a shot. You can go wrong, that's okay. This class is meant for going wrong. Even at times I go wrong. Yep.
I think yes. Maybe.
Will it be a linear equation? No, you don't think so. Okay. How about you, Shreyan?
I don't think it will be a linear equation. Because with exponent rules, you would just flip the y and the 1. So it would turn into y to the power of 3, so it would be greater than 1, so it wouldn't be.
Correct. Correct. Even if I trick you guys saying that x 7x minus y to the power minus 2 equal to 8, then also it will not be linear equation, because eventually what will happen is it will become 1 by y to the power 2, right? That's how exponents move from numerator to denominator. So eventually a more simplified definition of a linear equation would be an equation will be a linear equation if your power to the variable is 1 or 0. Keep it that way so that it doesn't come back with a different argument which proves our concept wrong. If I say y equal to 7, will this be a linear equation? Yes, it is a linear equation, because I can as well write this as this in 0 into x to the power 0. So I have both the variables x and y, but this will nullify to become 0. So y equal to 7. So y equal to 7. Whenever y is 7, this horizontal line will become your linear. Will be your line, or that, and this is the equation for your linear equation. Are you with me so far?
Yeah.
Okay. So now let's go back to what we were trying to learn with respect to the x and y intercept. So in the simplest form, the point where your line hits the y-axis, that is your y-intercept. The point where your line hits your x-axis or crosses your x-axis, that will be your x-intercept. Now let's look at it mathematically. So let's say I'm saying that y minus 3x plus 8 equal to 0. And I'm saying that this is a linear equation. And you have no choice but to deny this. Not because I'm forcing it on you guys, but I'm saying that based on the understanding we have built, or we know, that if my power to the variables is 0 or 1, then it's a linear equation. Now, what is my variable? Y and x. What is the power to y? 1. What is the power to x? 1. This is a constant. So, here it aligns with our definition of a linear equation, which says that if the power to my variables is 1 or 0, that's a linear equation. So, this is a linear equation. That is what is to be believed conceptually. Now, you still would want to check that, and there's a very easy way to do it. First thing is you just create a table of x and y values. And as I have defined in the past or explained in the past, when you talk about an equation, it is nothing but a contract. You guys have taken admission in school. What is the contract? The contract says that you will come to the school every day, or for a certain percentage of the classes you will attend. You will make sure that you give all your tests, submit all your assignments on time, and secure the minimum percentage needed in the exam to be able to stay aligned with your education policy for that grade. So similarly here, this is the contract between x and y. Any equation that you look at, be it a linear equation or a quadratic equation, even if I'm talking about a quadratic equation, this is a contract between x and y. That x and y value will adjust itself in a way that it meets the contract. So let's not go to quadratic equation for now. Let's stay with linear equation. And what it is saying is, this is a contract between x and y such that the value of y minus 3 times the value of x plus 8 will be 0. This is a contract as per this equation. Meaning you can play around with the value of x and y to get this outcome. Now let's play with that. So let's say if I'm saying x equal to 0, let's see what will be the value of y. When x equal to 0, y is minus 8. This becomes 0, and then y goes to the other side, plus 8 becomes minus 8. So y equal to minus 8. Now second condition is when I say y is 0. Let's say when y goes 0, what happens to x? When I put y equals to 0, it becomes minus 3x plus 8 equal to 0, or 3x equal to 8, or x equal to 8 by 3. Okay. Unknowingly or on purpose, I have found the x and y intercept. Now you will ask me why and how. Let's do that. I have 2 points, 0 and minus 0, 0 and minus 8, 8 by 3 and 0. Let's see, this is my coordinate plane. This is 1, this is 2, this is 3, this is 4, minus 1, minus 2, minus 3. This is 1, 2, 3, 4, 5, minus, okay, let's say 2, 4, 6, 8. I'm just using little different unit, okay, so that I can accommodate this in the space I have. So this is minus 2, minus 4, minus 6, minus 8. And as you all would be knowing, when you have a coordinate plane, you can decide your unit. Every block, how much the value would be, that you can always choose. I mean, if you have to plot 5,000 and 10,000, you'll pick one unit as 2,000, and then you'll have five blocks or 5 units to represent 10,000. So this is my x-axis, this is my y-axis. Now 0 and minus 8. When x is 0, y is minus 8. So we are talking about this point on the y-axis. This is my first point. Now second point is when x is 8 by 3, meaning 8 by 3, it is more than 2, less than 3, somewhere here. When x is 8 by 3, y is 0. So we are talking about this point. You join these 2 points. Look at this. What became your x-intercept? Where it is hitting the x-axis? Where y is 0. What is my y-intercept? Where it is hitting the y-axis? At this point, 0, minus 8. So your y-intercept from this one, you can say it's minus 8, and your s-intercept is 8 by 3. This value. Yes, Rian.
How did you get the x-axis to be 8 over 3?
So here, I had no plan of plotting this here, okay. I knew that, okay, this is my contract, okay, this is my linear equation, where it says my x and value will adjust in such a way when my value of y changes by something, or for whatever value of y, x will adjust in a way that all this sum will get me a 0. So here what I did, I put, first thing I did was, let's say when x is 0, I put x equal to 0 here in the same equation. So this part became 0. So y plus minus 0 plus 8 was 0. So y it became minus 8. This 8 moved to this side and plus became minus. So y, value of y was minus 8. So when x is 0, y is minus 8. That is how it satisfies this condition. Now I'm saying, okay, fine. I saw value of y changing for x equal to 0. Let's see what will be my value of x when y is 0. So in the same equation, I put y equal to 0. 0 minus 3x plus 8 equal to 0. Now, so this 0 can disappear. Minus 3x plus 8 will be equal to 0. Or if I move this guy to this side, it becomes 8 equal to 3x. Minus becomes plus. So now x equals, meaning I have to move this guy to other side of equal to sign, and since it is a multiplication, it becomes a division. It moves this way or this way, right? So it's the numerator comes to the denominator. So x equals 8 by 3. That was the way I got x equal to 8 by 3 when y is 0. Yeah. So from this one, I had no plan to kind of find out the x and y intercept. Just because I was lazy, I was trying to go for easier calculation. I put the value of x equal to 0 and y equal to 0 and found the corresponding value of the other variable. And I got 2 points, x and y coordinates for the second point. I just joined them And then I realized that when my x is 0, y is minus 8, that is where it is hitting the y-axis, which is my y-intercept. When y is 0, x is, sorry, when x is 0, y is minus 8. This is where it is hitting the y-axis. When y becomes 0, this is where it is hitting the x-axis. So this is my x-intercept. Yeah. So this was a pleasant surprise. We found the x and y intercept without purposefully trying to do that. But I mean, it might sound like a pleasant surprise, but you can always find it by yourself also. Now, look, think about it this way. If you have a coordinate plane, any point you pick on the x-axis, what will be the value of y? 0? Shara, Neil, do you agree? Srivatsav, Rehan? So, any point on the x-axis, if I pick, the y value will be 0. Similarly, any point that I pick on the y-axis, the x value will be 0. Again, let me repeat. Any point that I pick on the x-axis, y value will be 0. Any point I pick on y-axis, the x value will be 0. Correct? Now, so it's contradicting, okay? When you are picking something on the x-axis, y is 0. When you are picking something on the y-axis, x is 0. That means, if you have to find out x-intercept, meaning where it is hitting the x-axis, meaning y value will be 0, your y value will be 0. So if you are trying to find out x-intercept, Nihan, you have joined a little early. Okay, now Nihan got scared by hearing about the coordinate planes. Alright, so if I have an equation, from that I just want to find out the x-intercept, meaning where it will hit the x-axis. Now since we know or we have seen that something to hit the x-axis, on the x-axis y value is always 0. So if in this equation I just put y equal to 0 and find out what is the value of x, that is exactly where it's hitting the x-axis. So if you have to find out the x-intercept, put the y value equal to 0. If you have to find out the y-intercept, put the x value equal to 0. That becomes your thumb rule. So in this equation, if I just give this equation, if you don't want to put that much effort of making the table, then plotting it and then doing all that, you can just go with your conceptual know-how of the fact that if you have to find out the x-intercept, meaning something, a line which is hitting the x-axis, y value is 0, I'll just put y equal to 0 in this equation and find out the x-intercept. So let's do that. 0 minus 3x plus 8 equal to 0. So 3x will be equal to 8, x will be equal to 8 by 3. This is where it's going to hit my x-axis. Meaning, on the x-axis, wherever the value is 8 by 3, that is the point where it is hitting the x-axis. Similarly, if you have to find out the y-intercept meaning where the line is going to touch the y-axis. Don't have to worry about it. Just imagine that, okay, where it's hitting the y-axis, meaning the x value will be 0. If I put the value of x equal to 0 in this equation, that is where I'll get the y-intercept. Just put the value of x equal to 0. So y minus 3 into 0 plus 8 will be equal to 0. So y will be equal to, this is 0. So y will be equal to minus 8 when this guy goes to this side. So this is the point where it is hitting the y-axis. Yeah. So this is fairly straightforward. Now, see, it's not about being able to solve something. If you have a linear equation, you can always make the table, draw it on a coordinate plane, find it out. Nobody is stopping us from doing that. But what is happening actually for us? We are always going to be hard pressed in an exam-like scenario for time. That means more the time saved, more the time you will have for tougher questions. There are some questions that you cannot do quickly. You have to save time for it. And so that is where all that we do, we have to always think and figure out the fastest and the most accurate approach for solving it, so that you are not able to only solve the problem, but you are actually always forward looking. You are saving time for yourself for the other difficult problems that you are about to get in touch with. So here, if I say I have an equation, let's say 3x minus y by 2 plus 8 equal to 0, find out the x and y intercept of this one. What will be your approach? First thing you will say, okay, is this a linear equation? Power 2x is 1, power 2y is 1. Yes, it's a linear equation. Now I'm talking about finding out the x and y intercept. Now conceptually, okay, y intercept meaning where it is cutting the y axis. Wherever it cuts the y axis, the value of x will be 0. Put the value of x equal to 0, you get the y intercept. Similarly, put the value of y equal to 0, you get the x intercept. Now let's try solving one problem. I want you guys to kind of just break your head a little bit with this concept, or at least apply what we have learned. So we have an equation called y equal to 7 by 3x plus 9. Find out the x and y intercept of this linear equation. And you guys have 3 minutes for doing that. Let's see.
Wait, what is it? Y equals 7 by 3x plus what?
9.
Okay. What are we? X and Y intercept?
Yes, I want you guys to find out the x and y intercept of this linear equation. And my request to everybody would be, give it a shot, no matter whether you go right or wrong. Dave, Aryan, Dhanushri, Chris, Neil, Sarah, Prisha, everybody, okay? Tehan, Savya, everybody. I would want everybody to give it a shot and tell me the answer in 3 minutes or less.
Y equals to 9 and x equals to negative 27 by 7.
Okay. Okay. I think you got it, but we'll see what everybody does. Yes, Vishal.
I think it's -3 and 9.
What?
Negative is the x intercept.
X intercept is how much?
-3,
Okay. Y intercept is?
9.
Okay. Got the same? Right?
X is negative 27 by 3.
Okay. Yes, see what's up.
Sure, I got the same thing, but I got I didn't simplify the -3 part. I got negative 27 by 9.
27 minus 27 by 9. Okay. Alright. Anybody else? Prisha, Chris, Dhanushri. Yeah, Prisha.
I got x equals -3 and y is 9.
Okay. How about you, Chris?
Yeah, I got the same thing.
Okay. You guys are becoming good friends. Everybody is giving the same answer. Okay. Okay. Now, the most hated statement of mine. I don't trust anybody. I mean, again, I'll not repeat why, but simple terms. When it comes to math, you are the best judge always. So everybody has solved it. Let me solve it my way, and we'll re-verify. So Pradeep, you might want to just look at what I'm doing. So my first check is this a linear equation? Answer is yes. Y to the power 1, x to the power 1, linear equation. No confusion. Now, x intercept. See, I'm not doing anything. I just have drawn two lines. For being visually correct, y intercept, meaning where it is cutting the y axis, meaning where x will be equal to 0. Along this line, x is always 0. Okay. So if I put x equal to 0, I'll get a y intercept. So I'll just put x equal to 0. This part becomes 0. Y equal to 0 plus 9. Or if you want to still be explicit, 7 by 3 equals 0 plus 9. So y equals 9. So y intercept is 9. No problem. Now x intercept, meaning where it is cutting the x-axis, here or here, we don't know. But wherever it is, be it on the positive side or negative side, the value of y will be 0. So if I put y equals to 0, that will give me the x intercept. So y equal to 0 equal to 7 by 3 x plus 9. So this becomes 7 by 3x will be equal to minus 9. So x will be equal to, we know that this happens this way. So whatever is my denominator becomes numerator. Minus 9 into 3, 7 comes down. 9 times 3 is minus 27 by 7. Now, does everybody know why I don't trust anybody? It's not, I'm not trying to say that you guys are not knowing what to do, but what happens is sometimes we rush through the problem. Okay? When you rush through solving it, you would have done a lot of things in your mind. Wherein, I being a less intelligent person, I did it manually, without any assumption. I even have drawn this thing. This did not take me more than 3 seconds. But at least I was conceptually right. Okay, y-intercept, x is 0, x-intercept, y is 0. Then I substituted the value in this one and I got the answer. So again, everybody solved it. Some of you got right answer, some of you got different answer. But then, is this approach fine? Is this what you would want to take as an approach going forward? Yeah. Can somebody, see again, I'm not trying to make anybody feel good or bad, but can somebody tell me, see again, I have no shame in acknowledging that I have made so many mistakes when I tried to solve problems, okay? You guys are better off. You sometimes, you just hear some comments. For us, when I'm solving problem in front of my dad, if I make a mistake, the repercussions were way too different, okay? I would not want to say it on a camera because it's getting recorded and will go on YouTube also in the public domain. But during our childhood days, the repercussions were different, okay? But then those were not to make me feel bad, it was to make me be more cautious. A question like this, which is a cakewalk, which can get you a perfect score, if you miss, you might get, instead of getting 800, you might end up settling down for 795, 790. That is what I don't want. I want everybody in my class to get 100, 800. I mean, that's my aspiration. Even if you guys get 795, I'll not be unhappy. But I'm saying, we should shoot for the best so that you're settling for just a notch below. If you shoot for 750 in math, you might end up settling for 730. Go for 800. And that will come with practice. That will come with the statement that I made, that don't trust anybody. Even if your best friend, even if the smartest child in the class says that, okay, this is the solution, do it yourself. Yeah? A lot of gyan, but yeah, concept is about practice. Okay. Now, can somebody tell me why did you guys get a different answer than this one? Where did you go wrong? Are you guys shy of acknowledging it? I want you to say it because when you say it, there's a guarantee that you'll not make similar mistakes in your exam. Making a mistake in the classroom is no problem. Is somebody brave enough to tell me where did you go wrong? Yes, Vishal.
I think what I did was I was trying to find the y where it intersects at the y and where it intersects at the x.
Okay.
I actually found that instead.
Okay. So this is where this useless drawing might have helped you. Correct?
Yeah.
Yeah. So basically, see again, when you have to study in a class, you get bored. When you're watching a video on YouTube, that stays a little longer with you. What it means is the visual side of thing makes it much more easy to interpret. So make that into your plan. When you're solving problems, right? If I have to solve a problem like this, let me show you guys how much time any of us, be it me or you guys, in the exam, if somebody, there's a question saying, okay, 7y minus 8x plus 17 equal to 0. Find out the x and y intercept. Let me just do it, okay? My approach would be power of y, power of x is both 1. No doubt about this being a linear equation. It's a linear equation. I can find it out. So, linear equation. I know y intercept meaning somewhere here. X equal to 0. X intercept is somewhere here or here or here where y equal to 0. So let me put y equal to 0 first. Y equal to 0. So 0 minus 8x plus 17 equal to 0. Y equal to 0 meaning I'm trying to find out the x intercept. So 8x equal to 17. X equal to 17 by 8. I got the x intercept. Y intercept, well, x equal to 0. So I'll put x equal to 0. 7y minus 8 into 0 plus 17 equal to 0. So 7y, this is 0, equal to minus 17. So y equal to minus 17 by 7. How much time did I take? Probably a minute? A little more than a minute? My chance of going wrong is less. So never jump steps. That's the takeaway. You can do it faster, but don't jump steps because that is where there is a potential risk of going wrong. Is everybody with me so far? Risha, Chris, see what's up, everybody?
Yeah.
Yeah, okay. Alright, so Nihan and Mandeep have joined and they will end up learning linear equation and the slope intercept form of linear equation. Do you guys want to learn it now? No. It's way too early for you guys. You can join after 5 minutes so that you don't get scared of what you have to learn after 7 years, okay? Alright, so let's go to the next thing. So we talked about the slope of an equation. Meaning, if slope of a line, if I have a line like this or this, we know this has less slope or this is less steep, this has more slope or a higher steep. Can I find that out mathematically? There, like I said, I have equation like y equal to 3x minus 9 or y plus 2x plus 8, both are linear equations. But from this one, can I find out the slope of the line? So there is one standard equation. There is a standard form of a linear equation which is called ax plus by plus c equal to 0. Okay, this is called the standard form of a linear equation. We'll talk about the standard form, we'll talk about the slope intercept form, we'll talk about
Point slope.
say that again?
Point slope.
Point slope, yeah. So we'll talk about all that in the next class. We don't have enough time left for today, but we'll come back to this one. But every equation that you have, be it this equation or be it this equation, you can relate that to the standard form. You can move everything to one side and then you can see what is the coefficient of x, what is the coefficient of y, what is the constant term here. This becomes a standard form. There's another form which is called slope intercept form, which says y equal to mx plus c, where m is the slope and c is the y intercept. So if you have any linear equation, you can either look at this equation in the standard form or you can convert that to slope intercept form, and that is the fun activity we will do in the class tomorrow. Any questions so far?
No.
Whatever we learned or went through, I can guarantee you guys that 70 to 80% of the concepts that we are going to cover for SAT from now till end of May or beginning of June, you all would be knowing those concepts. what will make the difference is revising those concepts and then practicing them. Okay, you guys are doing it now, you will have to deal with it for next couple of years. I dealt with all these concepts 30 years ago. Okay, maybe 30, yeah, maybe 32 years ago. So some of the things are still with me, maybe because I have done practice, and I end up doing more practice when I'm teaching you guys. So practice is what will make the difference. That is my sincere request to you all. Whatever you learn in the class, you will learn, you will end up forgetting also. Only way you can retain or make it yours or keep it in your pocket always will be by practicing them all. And that's my only request to you all, so that you guys can make me happier by getting a near perfect score. Yep. Alright, with that being said, I will let you guys go. Have fun, and we'll meet again tomorrow same time.
Alright.
Alright, bye bye. Bye bye. Bye bye. Bye bye.
Bye.
Bye bye.